Okay, I gave my kids 10 questions today that would sort of represent things that they would need to know for this next coming test. I warned them that this was a little easier than the real test. All right, here we go. Number 1, cotangent. Well, you could have put 1 over tangent. That'd be good. How many of your peer tests, the ones you're grading right now, did that? 1 over tangent. All right, that's a good answer. Another option, what? Cosine over sine. That'd also be a good option. Okay, number 2. Sine of negative x. Well, there's really only 2 choices. It's either going to be sine of x or negative sine of x. Which one is it? Negative sine of x. Next one. The one with the tan is what? What we seek is what I say. Oh, I needed a beta there. All right. The next one. Tan is pi over 2, which is like 90 minus pi. Well, that goes with the cofunction of tan, which is cotangent. Cotangent of theta. Raise your hand if your kid did that correctly. Good. If they didn't, what do you want to ask me? Yes?
What if they said cotangent not of theta? Oh,
cotangent of not theta? What?
Cotangent.
Oh, they didn't say theta. Gotcha. Take off half of a point. We'll give them half. That means... All right. Moving along, number 5. Again. Okay. Sine squared theta minus 1. All right, that is not exactly one of those things on your chart. In fact, it's the exact opposite of one of those things that's on your chart. And so you should not have said that that was cosine. Because if you take this one, sine squared theta plus cosine squared theta equals 1, and then you move the the cosine to the other, the sine to the other side like this, you'd have 1 minus sine squared theta. And this is exactly opposite of that. So instead of putting what we normally would put, which is cosine squared, you should have put negative cosine squared of theta. And if you'd have watched the video from yesterday, you'd have known that. All right, and if you forgot that little negative in front, you're only going to lose half.
I actually got that right.
Good. All right. If they said, what did they say? It just says negative. Oh, negative cosine. The only thing they forgot was the square. Then take off half a point. All right. Moving on. Number 6. Simplify. Well, some of this will drop right out. Just tangent times cotangent. Those are inverses of each other, and they'll just drop out. Boom. They're gone because they're 1 over each other. So the next one is cotangent x. I'm going to replace that with, remember that little rule about changing everything to sines and cosines? It's one of those moments. Cotangent would be cosine over sine. Then the sines cancel. And then I have cosine times cosine, which makes cosine squared of x. There we go. All right. Moving along. Sine squared, I put it in parentheses to kind of give you the hint that you might want to replace that with something. And so you get rid of the sine squared and you put in 1 minus cosine squared. Now here's the leap that you needed to be able to make. You remember yesterday when I showed you how to take this and to split it up as a difference of squares? And then you could say that that's 2 times 2 sets of parentheses. And it'd be 1 plus something and 1 minus something. And 1 plus cosine x and 1 minus cosine x. All right. And that's all over 1 minus cosine x. And that's how you can get those 2 to cancel. 1 minus cosine x, 1 minus cosine x is gone. And what you have there is your answer. If they actually multiplied the 2 into both of them, that's fine too.
They just said 2 plus cosine. Does that count?
They forgot the 2 has to be distributed. 2 times this and 2 times that. So take off half of a point because they had it all right except for the number 2. Yes?
Never mind.
Okay. Any other questions?
Can you go back to the negative? If they forgot the negative on number 5, remember the cosine squared? You say half?
If they forgot the negative on number 5, yes, it was half of a point off. All right, moving on. Number 8. On number 8, you should have been able to solve this down for sine. All right, So sine x is equal to 1/2. And then, I know that one by heart. It's 30 degrees. If you didn't know it by heart, you'd have to draw yourself a little triangle. And you'd figure out that the opposite and the hypotenuse, and you go, oh, that's this one, and that's, what's this little angle? That's 30. And if I just said 30, would I be right? No, because it wants things between 0 and 2 pi. And I happen to know that one as one I memorized. 30 degrees is pi over 6. True or false? True. So pi over 6 is one of the answers, but then anytime it says all solutions, you should be thinking maybe there's more than one way I could get this. Sine is positive in 2 different spots. If I look at this, oh, students, take calc. Where is sine positive? Here and also here. So I can do that same triangle over here. And then I'll have 30 degrees here. And then I'll be able to say, oh, wait a minute, that is, if this is really pi over 6, then that means this spot right there is 5 pi over 6, because it's only 1 pi over 6 away from being a full pi. But anyway, that would be 5 pi over 6 is the other answer I think a lot of kids will forget. Okay, there's 2 answers, pi over 6 and 5 pi over 6. So they have one of the two, give them half. Yes? Okay, that means they didn't notice this part. Did they have everything else right? Take off only half then. All right. Number 9, hardest one of them all. Here's what you should have done. First of all, I hope you notice that it's a quadratic. Why is it a quadratic? Because it has something squared, something that's not squared, and then a number. That's a big hint that it's a quadratic. And then I would trade it for an x. I would let sine x equal x. I could say y. I guess I should probably say y. And then I'm going to say 2y squared minus y minus 1. And I just swapped out and made it easier because wherever I saw sine x, I put a y. Okay? And now I can factor it. And it might have taken you a while to factor, but it ends up being 2y plus 1 and y minus 1. And then I can go substitute back in again and say, all right, I've got to get 2y plus 1 to equal 0. 2y plus 1 equals 0. So I can now stick the y as sine back in here. 2 sine x plus 1 equals 0. So I stuck the y back, the sine back in for it. And then I put the 1 on the other side. And then I end up with sine x equals negative 1/2. And then there will be 2 answers for that. And then on the other side, I'll have sine x minus 1 equals 0. So sine x equals 1. And so there's only one spot where sine is equal to 1. In case you've forgotten, there's 2 ways you could think of this. Graph of sine. Do you see where sine is 1? Right there. Do you remember where that is? Well, if this is 2 pi and this is pi, what's that spot right there? Pi over 2. It's a good way to get it. Option B, you could do on the unit circle and say, where is sine or the y value equal to 1? 0, 1. Sine is right there, and that would work. And that's also pi over 2. So either way, it's pi over 2. It's one of the answers. The answer over here is, where is sine going to be negative? All students take calc. Sine is not negative here. Sine is not negative there. So I can cross those out. So then, I'm looking at these. And where would I have a 1? Sine is opposite of hypotenuse, and a 2 like this. Only if this was 30 degrees right here. But it's actually negative 30 or positive 330. And they wanted these answers in radians. And so since these are pi over 6s, it would normally be 12 pi over 6, but you take away this 1 pi over 6 at the end here, makes 11 pi over 6. And the last answer is, where else is it negative? I'll do that one in green, right over here. And that's got to be like a 30-degree angle or a pi over 6 right there. And so this is 6 pi over 6 plus an extra 1 makes 7 pi over 6. If anybody got that one right, you can be very proud of yourself. But it is a very realistic test question. R3 level, definitely. So I know you've probably already checked with the person grading yours. How many of you guys had that one right yourself? You personally had it right. 1, 2, 3, 4, 5, 6, 7. 7 of you. 8 of you. All right. If you didn't get it right, how many of you think you could get it right now that I've explained it to you? And you had it same problem again. All right. If you think you still be lost, then you need to come in the morning and get some help, okay? Because this involved quadratics, which we've done before. It involved factoring, which we've done before. It involves solving simple little equations like this, which we've done before. And it is, I know it's challenging because you got to think of two different answers that work, and you know, there's a lot of parts to it, but we've done all of this before. There's nothing new there. Yes, sir?
What if they only got 2 out of the 3?
If they got 2 out of the 3 answers, you can give them half credit. We're not going to give anything other than halves, so it's either half credit or whole credit. All right, moving on to the very last one. They will have proved it only if you look through their work and see that every substitution that they made is legitimate, and that the final answer comes out to be secant over cotangent. Or if they started with this side and simplified it down, then their answer needs to, of course, come out to this. Now, I want you to look through theirs in a minute. First, let me explain what is common strategies for doing this one. All right? First of all, would you agree that if I'm going to start this, that I could replace that cosine squared with a couple different things? Give me some options. Cosine is the same as 1 minus sine squared. I could do that. Yep. Cosine is the same as 1 over secant. I'll give you that. And why does that seem like it might be a good idea? Because there's a secant in this answer. All right. All right, so let's start with that one. Sine theta over, he said 1 over secant squared theta. And then I'd have sine times secant squared theta. Now, at some point you're going to have to do this little trick. Either it be here, like the way we started. Right now I'd have to figure out that you have to break secant squared up into 2 secants being multiplied. So I'm going to take this sine theta, set it aside for a second, and I break this secant theta into secant theta times secant theta. Why does that help? Well, I want to have a secant theta left in my answer here, but I don't need 2 of them. So I'm breaking it up. And now this secant, what do you think I'm going to change that to? 1 over cosine. If I change that to 1 over cosine theta, I'm going to bring everything else down. Then sine times cosine, sine over cosine is what? Tangent. Tangent times secant. Oh, I'm so close. Secant over cotangent. All I have to do is fix that tangent. What's tangent? 1 over cotangent. And that's it. Because that is secant theta over cotangent. And that's what I wanted it to be. Secant over cotangent. So I say equals, bring that other side down. Secant over cotangent. Now, the way I would have done it, I probably would have started by right off the bat breaking this cosine into cosine times cosine. I know your instinct is to change it to like 1 minus sine, but I would have made this cosine and cosine. Cosine times cosine makes cosine squared. Know why I would have done that? Because I would have known that sine over cosine would give me tangent. And then sine over cosine giving me tangent means I can really close to cotangent. Because tangent and cotangent, all you had to do is put 1 over, and you'll have it. All right, so that's the way I probably would have started it. So, yes, questions? Okay, if you look at their paper, and you can follow every single step that they did, that, okay, now they went to here, now they went to here, now they went to here, and now here's the answer, okay, then they get the point for it. If not, then ask them, hey, you know, like, they'll be honest with you. If they think they really nailed it, they'll tell you. If they're like, no, I didn't know what I was doing, they'll tell you. Okay? And if you can't figure it out together, then come ask me and I'll grade number 10 for you, whether or not I'd give them credit. Okay? All right, so talk with whoever you just graded and get it back to them.
Okay, so students.